Hi guys, Erin here. This week is all about non-experiments and quasi-experiments, which is the kind of research strategy that we tend to use in education or clinical settings. So likely this week is going to be relevant to you and your future work and possibly also for your research proposal. In this video, we're going to be talking about the similarities and differences between one way that we do non-experiments compared to correlational designs. Here's where this video fits into our course, into a research strategy. So to talk about this, I thought we should use an example. Let's say you're a teacher in class and you want to know, is there a relationship between how kids act in the class, the behaviors they show, and the amount and quality of sleep that they get? In particular, you want to know if there's a relationship between how impulsive, hyperactive, inattentive kids are. So these are traits that are typically associated with ADHD, and both the quality and quantity of sleep. Well, we can answer this question in two different ways, using both the correlational research strategy and a non-experimental research strategy, and it would be done in a very similar way. So in both cases, we would have teachers or parents, or in some cases the child themselves, fill out a questionnaire like this. This is the Vanderbilt ADHD diagnostic scale. It's used by doctors to be able to say to what extent a child may be at risk for ADHD or not. So participants, teachers, parents would think of the child's behavior over the last few weeks, read these statements, and rate the extent to which each statement applies to the child. So for example, has difficulty sustaining attention to tasks or to activities, never versus very often. They'd read all of these different statements, we'd tally up the scores to all of the questions, and a higher score on this questionnaire would mean more difficulties with inattentiveness, hyperactivity, impulsivity, etc. Similarly, we would also administer a questionnaire like the sleep quality scale. Oh, by the way, you can find both of these questionnaires for free online, and I've given the link at the bottom of the slides. So in this case, the child themselves thinks about the sleep that they've had over the last month, reads these statements and rates the extent to which each statement applies to them. Again, we tally up all the scores, get one score for the participant, and a higher score would mean that they would have more sleep problems. So we can look at the relationship between these two variables using the correlational research strategy. So this is made up data from 10 fictional participants. If you actually did this study for your research proposal, remember the law of large numbers, we would want at least 30 participants. So each participant here, we've got one score on the Vanderbilt scale, we've got one score on the sleep problem scale. We can plot the relationship between these two variables using a scatter plot. Again, this is a review from last week, each dot here represents one participant and their scores on each of these measures. This is a great chance to review. Why don't you have a look at this scatter plot and see if you can say for yourself what is the strength and direction of this correlation, and see if you can guess the R value. Well, we can actually get the R value by putting these numbers into Excel using the Pearson correlation coefficient, and here we have it here. So if this is something you're doing for your research proposal, check out your textbook, page 455 for more information. So if we actually collected this data and got these numbers, the kind of conclusion that we could draw from this study is that stronger ADHD traits tend to be associated with poorer sleep. People with higher scores on the ADHD scale tend to report more sleep problems. Now we can answer this question also using the non-experimental research strategy. In this case, rather than taking these scores on the ADHD scale and treating them in a continuous way, we can instead group participants based on the scores on this questionnaire. We can say anybody who has a score above a certain threshold, they would be deemed at risk for having ADHD, versus anybody who has a score below that threshold, they would not be at risk for ADHD. And now we can classify our participants based on whether they potentially do have ADHD versus don't, and we can group them based on this metric as being in group 1, anybody with low scores, not at risk for ADHD, versus group 2, who has higher scores and is at risk for ADHD. We can again plot their scores on that sleep scale measure. Here you can see that here. Usually we use what's called a bar graph, and I'll show you what that would look like here. So here we have our two groups, and the height of the bar represents the average in both of the groups. Here we've got the no ADHDers. That's the average for these scores versus those who have ADHD or who are at risk for it. That would be here. Again, if we would actually do this study in real life, you would want 30 participants in each group. So if we plot those numbers into Excel, we can get these bar graphs based on the average in each group. So this is the average sleep problems in our two groups here versus here. We'd also want Excel to tell us the standard deviation. This is a measure of how much variability there is within each group. And we can plot that here using these error bars. This is really important because we can use both the average and the standard deviation to be able to say confidently whether the difference between groups is both large enough and consistent enough for us to treat it as meaningful. And we can use a statistical test called an independent samples t-test to be able to say whether there's a significant difference between two groups. Check it out in your textbook for more information. So just like the conclusions we drew from the correlational research strategy, we draw the same conclusions in this kind of design. Our conclusion from this kind of made-up data would be that ADHD is associated with poorer sleep. People with stronger ADHD who have meet the criteria for ADHD tend to report more sleep problems than people who do not. So this is an example of a non-equivalent group design. It's a research study that compares groups of participants. And importantly, and unlike what we'll be talking about in the context of an experiment, the groups already exist in the real world. As an experimenter, we're not telling people whether they belong to the ADHD or the no ADHD groups. That is just the way they are. Another important feature of this is that groups are not equivalent because we're not creating the groups, we're not using random assignment to create the groups, and we're not measuring or controlling for any other variable that could also potentially provide an alternative explanation for the results. These groups are just not equivalent. In this particular example, this is also called a differential research design because our pre-existing groups are based on some characteristic of the people themselves. In this case, whether they have a clinical diagnosis or not. So the structure of this kind of design is always the same, where we've got two or potentially more groups, and we're looking to see whether the average score in each group is different from each other. So if we're comparing correlations versus non-experiments, in some ways they're very similar. They have the same goal, which is to describe the relationship between two variables, and both of these variables exist in the real world. We're not attempting to say one variable causes change in another, we're just describing the relationship. The one way that these two research designs differ is in the kind of data they use. In a correlation design, both of the variables are continuous and are measured using the ratio or interval scale, versus in a non-experiment or in a quasi-experiment, one variable is continuous. In this case, it was the sleep quality, and the other variable is categorical and uses the nominal scale. You either belong to this group or that group. So in a non-experiment or a quasi-experiment, we're either comparing two or more groups as they exist in the real world, or as we'll talk about in the next video, we can also compare one group at different points in time. We also, looking at the difference between correlations and non-experiments, they have the same benefit. Because we're not manipulating anything as researchers, rather we're measuring variables and behavior as they exist naturally, it is more likely that the results that we get from this study are going to generalize to people in real life situations. So we're not having people come into a lab and try to fall asleep in a very artificial controlled setting. We're instead asking people, how do you tend to sleep in an average night? So this is a good thing because we're more likely to get results that will generalize to the real world. The downside is that these two designs have the same limitation. We can say that two variables are related, but we can't say that one variable is causing a change in another variable. And this is because of the directionality problem and the third variable problem. So we might observe that kids who have ADHD tend to say that they have poorer sleep, but we don't know what's the chicken or the egg, because having poorer sleep may also and equally increase the increase somebody's scores on that ADHD scale. So we don't know what is causing what the direction of our relationship is. We also are not measuring any other variable that could provide an alternative explanation for the results. So we're not asking kids about their diet, about their exercise, about their home situation. All of those factors we know are going to impact a child's sleep, and they're also going to impact their behavior in school. Because we're not measuring those and we're not controlling for those, they could be driving this relationship. So it's very important that we don't say anything about one variable causing another. All we can do is to remember our goal is to describe the relationship. We can say that we observe a relationship. We can describe the relationship. One group is performing higher or lower, or that there is a positive correlation or a negative correlation, but we can't say why that is the case. So this is a great chance to review the concepts of internal and external validity. Feel free to pause the video, read this, and go back to the videos where we talk about it. If we treat internal and external validity as a scale on itself, non-experiments and correlations both tend to be low in internal validity, but high in external validity. Experiments are the opposite, and quasi-experiments, which we'll be talking about in the next video, tend to fall somewhere in the middle. So to conclude for all of this, what I hope that you'll get out of this is to be, well, first of all, understand how these two designs are similar and different, but also to be precise in your speech. Correlation and non-experimental research is about establishing if a relationship exists and describing the relationship. We're not trying to say one thing causes another. So we can't say in this case that having ADHD causes you to have poorer sleep or vice versa. We can just describe the relationship. So if you're going to propose to do this kind of research for your research proposal, please be very careful in the conclusions you draw. Similarly, as you're reading articles and in the future, as you come across results in the media, be cautious of sensational results that tend to say that one thing is causing another. This kind of conclusion is very hard to draw and requires a highly controlled experiment. If the design is instead correlation or non-experiment, then check to make sure that the conclusions make sense based on the way that the study was done. And remember, if a research design compares two groups of people, it's trying to establish if the average scores in one group is larger or smaller than the other group. We're not doing a correlation if we're comparing two groups of people. That's all for this video. Thanks so much, and we'll see you next time.